everyone. See you again. Now we go to the 5.4. There's a chapter 5, second last subtopic. So this one is a nuclear energy. So today I will continue our lesson. Hopefully you are ready for this topic. Okay, let me start this topic. Okay, let's see here. So the first one, we can see the atomic mass unit, AMU. Okay, we're going to see this part first. Okay, let's see the AMU. Actually, they stand for atomic mass unit. There's a unit of the mass for atom and subatom. Okay, atom and also the subatom. Okay, example here, the atom and subatom, that means we're using the example is you're using the alpha, beta and gamma, is it? That one is we need to count about the mass. So we're using this to calculate lah. So from here, let's see the first one. They got proton, neutron and also the electron. So from here, the AMU, for this all subatomic, actually there's a 1/12, the mass of the carbon. Okay, 1/12, that means there's a very small lah. So from here, we're going to see how to count about the mass. Okay, let's see the first part. Okay, AMU, you see 1/12 from the carbon. Let's see carbon is how many. Okay, after do the calculation, we find it, they become like this. Okay, 1.66 times 10 power negative 27. This one I think you don't need to memorize. The question they will tell you what is the AMU for the certain subatomic. Okay, now you're going to see the example 1. Example 1, just a simple question and they just want you to convert. Okay, you have me to convert. After that, we know the answer. So you do now, please. So I'll do some changes first. Okay, let's see here. The mass of the carbon. Okay, you see, cobalt 60. Normally they say the 60, actually there's a round number. There's a 59 point something. After that, can you see the U? U actually is a AMU. They don't need to write the full. They just write the U. Okay, now this one unit is in AMU. They want you to convert become kilogram. So we straightforward to take the 59. Okay, please you need to using the full number. Cannot say you short become 2 decimal point. Okay, we take the full number. Okay, after that you need to multiply with 1.66 times 10 power of negative 27. Now you convert become kilograms already. So your answer here should be very small lah, 9.9490. Write the full number lah, times 10 power of negative 26 kilograms. Okay, so this one is how to convert the cobalt. Okay, the mass of the cobalt from the AMU become the kilograms. Okay, now we go and see the first part. There's a nuclear fission. This one is one of the nuclear reaction. So before that, we learned about radioactive, is it? So this one is one of the process, nuclear fission. Okay, nuclear fission. Okay, this one is a definition. Okay, must remember, when they ask what means on nuclear fission, this one is a definition. Nuclear fission is splitting of a heavy nucleus. Okay, this one is a heavy nucleus. Okay, they got one of the neutron, they hit the heavy nucleus. After that, the heavy nucleus will split, become 2 lighter nuclei. Okay, this one is a 2 lighter nuclei. So they come out is what name, how many proton number, how many neutron number, we no need to know about that. We just know this one process is from the heavier, then they split, become 2 lighter. Okay, and also they split with the 3 neutron. Okay, so this one is a nuclear fission. From the big size, split becomes small size. Okay, let's see the number 2. Fission occurs when the nucleus of an atom is bombarded. Okay, we never say they hit. We're using bombarded. That means they bomb together with the neutron. So that means this one, because the heavier nucleus bombarded by the neutron. Okay, now what happened? The energy of the neutron. Okay, causes 2 or more nuclei that are lighter than the parent nucleus, releasing a large amount of energy. So that means these two, we can say there's a daughter lah. The new daughter to come out. After that, large amount of energy, and also 3 or 2 neutrons come up together. So this one we call the process. So that means this one is before. Okay, this one is a before. Okay, neutron bombarded with the heavy nucleus. Okay, this one is after. Okay, after that you can say 2 lighter nuclei produced, and 3 or 2, either 3 either 2 lah, the neutron will come out together, and one more, don't forget, energy, large amount of energy. So that's why this one we call nuclear energy. Okay, let us show you some diagram. Okay, this one, can you see this one is a nuclear fission? This one is an example lah, target nucleus, then the neutron to hit, bombarded, then produce the 2 fission product. This product must be lighter, and 3 neutrons. Okay, then we're going to see the second diagram. Okay, this one is what I want to show you. Okay, now we continue the following. Okay, this one is an equation. Okay, let's see the equation here. When the uranium-235 bombarded by the neutron, okay, we're using the word bombarded, is split into 2 fission fragments. Just now I told you the fragment. That means there's a lighter nuclei. Here they come out is a strontium 90 and xenon 143. After that, 3 free neutrons come out together. Okay, so from here we can see the equation how to write. Let's see the equation. Okay, first one we write the uranium. Okay, we separate first. Okay, this one is a before. This one is a after. So first one, before is a uranium bombarded by neutron. So we check the proton number, the nucleon number. Nucleon number is 236. Proton number is 92. So that means final. This one is a final, is it? After do the nuclear fission, the proton number and the neutron number, nucleon number must be the same. So you see it. Xenon is 143. Okay, strontium is 90. Okay, they come out 3 neutron. 3 neutron means 3 lah. So finally, I find it there's a 236 also. Energy, we never count anything, but you need to write. Okay, proton number 54 plus 38. Okay, then plus 0 lah. So final, still 92. So you see before and after, nucleon number, proton number must be the equal. Okay, so this one is an equation for the radioactive. Okay, no problem, is it? Then we continue. Okay, now we're going to see chain reaction. Chain reaction is a one of these neutron bombard another uranium-235 nucleus, then more fission will occur. Okay, what means more fission will occur? After that, they're releasing the neutron. Then chain reaction will produce. Okay, this one situation is first time you do the nuclear fission. Okay, after you do the nuclear fission, you will come out 3 neutron, is it? Okay, you will come out daughter, 2 daughter, 3 neutron. Okay, now these 3 neutron, they will go to find uranium. Okay, they will each neutron go to find each uranium. So you think about that. When they find another 3 uranium, what happened? Fission again. Then fission again, they come out 9 neutron. Yes or no? 1 uranium come out 3 neutron. This one also 3. This one also 3. Finally, this whole thing will continuous. So this one situation, we call it chain reaction. Okay, so from here they explain for you. As the uranium atoms, they continue to split. Now the significant amount of energy released. So this one situation, they should produce many of the heat energy. So the heat release, then harness, and also they use to generate electric energy. So that's why they're using the power station for the nuclear power station, because they can produce much of the energy, then they can generate electrical energy. Okay, let's see example for the chain reaction. So this one is the first generation. Okay, after that this one is a second generation. Can you see the neutron go to find another uranium? Okay, after that this uranium will produce 2 again neutron. Okay, then these 2 neutrons will go and find uranium again. So you find it continuous. Every process, every generation also produce the energy. So this part also energy, this one also energy. Finally, what you think about the whole process energy? That means the energy must be much and much. So this one we call chain reaction. So from here, the control chain reaction, we use power station. Okay, power station means you can generate electricity lah. If uncontrolled one, what we need to do? Uncontrolled one, that means we become the nuclear bomb. Okay, as a nuclear bomb, that means it's more dangerous already. Okay, so I show you the diagram for chain reaction. Okay, we go to the number 4. Okay, this one is one of the diagram of the chain reaction. You can see the neutron will be more and more. Okay, another diagram also same. So the pattern is almost the same lah. They come out the lighter nuclei, then come out the neutron. Then the neutron will go and find another uranium. Then the continuous. The process will be continuous. Okay. So now we go and see go back to see our notes. Okay, we go to following part. Now we go and see the critical mass. Remember the word of critical. Okay, critical means the special one. Remember we learned about critical temperature for the superconductor. Then we learn about critical angle for the light, how they're deflected. Critical means the certain, okay, depends the material, the certain mass or certain angle. So now we're talking about the mass lah, critical mass. Okay, in order the chain reaction, okay, just now I explained chain reaction. The sample of the uranium must have critical, certain minimum mass. We call critical mass. Not every, okay, not every of the uranium that can happen about the chain reaction. No, okay, I never say. Okay, they must have the critical mass. After that, the chain reaction will happen. So if everything can happen, then die already. We cannot control already. So they got certain mass. Okay, they will happen the chain reaction. So this one we call critical mass. Okay, let's see the following. There's a graphite. Okay, moderate. Okay, because this one chain reaction will happen, is it? So that's why in the power station, this thing is inside the power station. Okay, they're inside the power station. Okay, they must have this one graphite as the modulator to control. Okay, to control the nuclear fission. Okay, that means they control the nuclear fission, means they never so fast to go to hit the uranium. So that means they control the chain reaction by using the graphite as a modulator. Okay, modulator. Let's see the example for the graphite here. Okay, I just show you the diagram lah. Okay, so this one they're using the cool water in, hot water will out. Okay, they want to cool down because this whole thing, the process to produce the heat energy is too high. So they're using the motor actor. So from here, this part, we call it the whole thing is a moderator lah. The black color one, okay, the black color one, control rod. Control rod. So this one is a uranium. The red color is a uranium. This whole thing later I will more detail to explain in the power station part. Okay, you just know graphite as a moderator. That means they want to slow down the whole process of the nuclear fission. That means when I just slow down, that means chain reaction can be controlled lah. If cannot control, that means bomb already. So that's why this one is as a moderator. That means we can control the nuclear fission. Then after that, the chain reaction just occur. You produce a normal energy to generate electricity. Okay, so this one is a graphite as a moderator. Okay, now we go to the second page. Okay, this one is another diagram for the graphite. Okay, this one is of graphite. This one is more clear. You can see the movable control rod. Then we got concrete shell. This one must be closed. Do not let the radioactive or the energy escape. Okay, you see the graphite. Graphite is a black color. This whole black color, we call it as a graphite. So from here, bottom is a coolant. The coolant, the water, normally using water. This one is a hot coolant to come out. Okay, after that, this one we got vessel, we got reactor. Okay, so this one is a one part of the radiation. That's a reactor part. Okay, then we go through to our second page. Okay, let's see the second page. Okay, second page, they just want to explain the graphite lah. Just now I told you what's the function. Okay, let's see the graphite. Okay, they say the neutron they produce in fission reaction is very fast. The neutron is very fast. Okay, that's why you need to control the neutron. So slower the neutron are more easily to capture by the uranium nuclei. So you need to slow down the neutron. If you slow down the neutron, that means chain reaction can be reduced. Okay, graphite can be the moderate, okay, to slow down the chain reaction. Okay, so they will occur, the chain reaction to occur at the smaller critical mass. So that means important the graphite is slow down the whole process of chain reaction. Okay, because the neutron too fast already. So you need to control lah. So how to control? So we control the movement of the neutron, the motion. You can make the neutron become slow. Then after that, the chain reaction will be slowed down. Okay, so this one is a nuclear fission. Okay, now I need to go is another process for radioactive. This one we call fusion. Okay, make sure the spelling you need to know. Just now is F-I-S-S-I-O-N, fission. That's from biggest become smaller. Okay, now is fusion. Fusion is terbalik. Now you see fusion, what they're talking about. Nuclear fusion is combining. Okay, they want to combine. They don't want to split. Combine the two lighter nuclei to form the heavy nucleus. So that means they opposite with the fission. This one they want to combine the two lighter one. Okay, after that they become the heavier nucleus. After that they also release large amount of energy. So from here you see example for deuterium, okay, and tritium. They do the nuclear fission, nuclear fusion. After that they produce a heavier one. There's a helium. Okay, come out also large amount of energy and also one neutron. Okay, one neutron. So they come out one of the neutron. So this one is another process, produce a nuclear energy. Okay, let's see here. Nuclear fusion is processed by energy is released by the sun. energy released by the sun means solar energy. Okay, they're processed by energy, that's a release by the sun. Okay, when two hydrogen nuclei, that means the deuterium and tritium, they're moving in high speed. After that, they collide. They will join together to produce a heavier nucleus. So when they join become the heavier nucleus, now a large amount of energy also will be released. Okay, so this one energy release, they take it as a solar energy. Okay, so from here we know about nuclear fission, nuclear fusion. Okay, we see some diagram about the fusion. Okay, let's see the fusion. Okay, same lah, this one as your diagram. They join together, split become the heavier, become the helium. Okay, we're going to see the animation. Okay, they join together, fusion. After that, they produce helium and one neutron. Okay, this one is an example. Okay, so we continue with the lesson. Okay, the following, there's a calculation. Okay, let's see the calculation. Okay, now we're going to see nuclear energy. The last one we need to count about nuclear energy. Okay, let's see the nuclear energy. First one, they're talking about what means the nuclear energy, how to do the calculation. Okay, they say the sum of the masses of the particle before reaction is more than. Okay, are you agree or not? Normally before reaction, the mass must be more than the after. Why? Because you release, okay, you release what? Energy. When you release the energy, that means you lost some mass. So from here, when we do the calculation, we just do minus. We take the before, go to minus the after, then we find it. The answer is how many? That one, we call it mass loss. Okay, energy released from the both nuclear fission and fusion. Oh, sorry, not mass loss. There's a mass, after you calculate, that means, there's a mass loss. You can say about the mass defect also. So that means we need to count is how many energy already lost. Okay, so from here, the energy lost it, then we just assume there's a mass loss. So they put equal. Mass loss equal energy release from the both situation. So this one mass loss, we call it as a mass defect. Okay, total mass before reaction minus total mass after reaction. So this one we call mass defect. So the relationship between the mass and energy, we're using the formula is E equal mc square. Okay, E equal mc square. E is a nuclear energy. Okay, we're still using the joule. Okay, mass is a mass defect. Just now I told you, you need to minus before minus after, so we get it as a mass defect. C is a speed of the light, 3 times 10 power of 8. Then you remember, go to square. Okay, so this one is nuclear energy, the formula E equal mc square. Now we're going to try example 2. Okay, now they show you the polonium 210 undergo the alpha decay. Okay, now you can see alpha decay. They come out alpha. Okay, become the plumbum 206. Now the equation for the decay. They show you the equation. Okay, now can you see the additional information? Okay, you see the polonium. Polonium, the neutron number 210 is it? Suppose the actual is a 209.982 is it? Okay, you remember atomic. So just now I told you, you need to multiply this one when you want to convert become kilograms. Okay, after that they got PB, the lab. This one is a mass. After that they told you the helium some more. Okay, now the first part, using the equation, you need to calculate the mass defect. Okay, you want to calculate the mass defect, that means this one is a before. You need to separate before, after. So you take the mass before minus the after, then you find it the mass defect. Okay, one more thing. Don't cut the decimal point. We're using the full one. Okay, let's see the A example. The U we do want to change first. After minus, then we go to change. If you change, there's so many decimal point already. So better we do it 209.982. Okay, U, you go to minus. Okay, PB 205.969 U plus helium 004 U. Okay, then you minus, you can see you left how many U lah. So from here I get it, the answer is 9 times 10 power negative 3 U. Okay, this one is the mass defect, but the final answer I don't want U. The final answer I want in kilograms. So you go to multiply the 1.66 something lah. So after that I write my answer. Okay, better you put 4 significant figures. Okay, times 10 power of 39. Okay, 39. So after that, sorry, 29, not 39. So power of 29. Okay, where's my pen? Okay, power of 29, negative 29. Then you put kilograms. Okay, so this one is a A. Okay, now after you find the mass defect, that means we can see the B. B is the energy release. So energy release is E equal mc square lah. We're using the formula. So your answer just now you find the mass defect, you put in. So the C, the question give you already. Remember, go to square. So I straightforward give you the answer. 4 significant figures, don't cut the numbers. Okay, 3, 4, 5. Okay, times 10 power of negative 12 joule. So better you check. So I show you, I straightforward show you the answer. Okay, C, power generate in 2 ms. Ms means what? Millisecond. Okay, remember the power formula. Power formula is energy over the time. So you get energy already, is it? So you take your energy just now, joule, over the time. Okay, milli is how many? 2 times 10 power of negative 3. Okay, you help me to convert. Okay, final, your answer should be in watt because it's power. So I get it, there's a 6.7, 6.723. 23 times 10 power of negative 10. Okay, W. So this one is my answer for the power. Okay, I repeat, 6.723. Okay, see clear? Okay, then we go is example 3. Okay, a possible fusion reaction is represented by the following equation. Okay, same again. So they want to calculate the energy. So you want to calculate energy, you write the equation first. Excuse me. The M, you must find out the mass defect. So we go to separate. This one is before, this one is after. So that means you take the first one, deuterium H2. Okay, 2014102 times 2 first, because you got 2. Then you need to minus 3, 016049 plus. Okay, another one is 1.007825. Okay. Okay, your answer must be U lah. After that, you calculate, then you multiply with the kg. Okay, convert to come kg. So from here, I get it, there's a 4.33 times 10 power of, okay, times 10, okay, times 10 power of, how many? Power of negative 30, negative 3 first, 3 U. Okay, now I convert, become kilograms, 7.188, okay, times 10 power of negative 30 kilograms. Okay, I get the mass defect. So as I get the mass defect, now I can convert become nuclear energy. So straightforward, you do the E equal mc square. So our final answer is 6.469 times 10 power of negative 13 joule. So I can show you this one is a straight final answer lah. You can do your calculation. The number is too large. So when you press your calculator, be careful. Okay. So, okay, the calculation, I think there's a no problem. Okay, it's no problem. Now I need to explain about the power station. Okay, let me go and see the power station first. Okay, I change the slide. Okay, let's see the power station. Okay, first part I want you to label. Can you see I label all the number already? Okay, you follow me to label the number. Uranium is number 1. Okay, this part just now I show you graphite. Okay, number 2, you help me to label there's a hot gas. Okay, number 3, we got 2 parts. Steam is number 3. Pump water here also is number 3. So that means the procedure 3, we got 2. We got 2 situations. Okay, after that we go to generator, part generator. We got 2 part 4. Okay, 4 you can go about the coin and magnet. Another 4 you can go to pump here. Okay, the water pump here. And the last one should be the 5, the last one, generate electricity. Okay, you label first. Okay, after the diagram you label. Then I want to show you the words, the explanation we also need to label. Okay, let's see here first. I show you the number. Okay, this one is a number. Okay, you help me to label first one. Okay, fission of uranium. So later you just refer this one notes. I never show you this one notes, I just show you the diagram. So fission uranium, your label is 1. Okay, number 2. Number 2, there's a gas passing through. Okay, number 3 here. Okay, number 3, cool gas go back. Okay, remember number 3 we got 2 situations. Now this one is number 3 also. Okay, part 4 also got 2 situations. Steam go back, another steam go to drive the turbine. Okay, last one. 5 is go to generate electricity. Okay, so now I want to go back to show you the diagram. So you refer the notes. Okay, when I just say part 1, you refer the notes, you're going to see what they explain for you. Okay, so I turn back. Okay, let's see here. So I explain the diagram. Okay, first part, can you see we separate by 2 power station. This one is a power station, nuclear power station. We separate by nuclear reactor and nuclear generator. First one is a reactor. Reactor, that means you want to happen nuclear fission. Okay, after that you produce a heat. Okay, now you want to generator the electricity. So this part we call generator. Okay, now we're going to see the every part function first. Okay, uranium rod. Okay, find uranium rod. The first one, number 1, the dark color one. Okay, this one is to produce the nuclear power. Okay, produce the nuclear power. Okay, when the fission, okay, fission, we never using fusion, fission. Reaction occur in the uranium rod. That means from this one situation, the part 1, there will happen nuclear fission. Oh, wait lah. Okay, nuclear fission will happen here. Okay, nuclear fission, that means together with the bombarded neutron, together with the uranium. After that, they produce a 2 lighter nuclei and neutron. Important is energy. They need to using the energy. Okay, let's see the graphite coal. Okay, graphite coal, the dark color one. That as a modulator, slow down what? Slow down the fast neutron. Okay, do not let the neutron come so fast. So this can slower the neutron. are more rapidly captured by the uranium nuclei. They can capture. Okay, they come out so far, is it? They can make it become slow down. Okay, so this one is a graphite coal function. Okay, sometimes they're using graphite. Okay, so from here we're going to see the next one, boron. Okay, boron control rod. Let's see the diagram. The boron, this part. Okay, boron. Okay, boron control rod. Boron control rod that absorb the neutron. Okay, just now it slowed down the neutron. So if still cannot slow down, finally the boron they need to absorb lah. When they absorb, that means they control the rate of fission. That means absorb, that means you don't have any fission already, is it? So from here, they straightforward, they control the rate. When the rod are lowered into the reactor core to absorb some of the neutron, so the rate of the fission will be reduced. Okay, just now just slow down the neutron. This one straightforward go to absorb the neutron. So that means the whole process can be less. Okay, now we see the concrete shell. Concrete shell, they want to prevent the leakage of the radiation. Because you produce so many radioactive, is it? They want to prevent to come out. Okay, heat exchanger. Heat exchanger is the last part, the bottom here. Heat exchanger. So from here, this one, heat exchanger, actually they want to change. You see the heat energy from the very high hot gas is used to boil the water. That means they produce a high gas, very heat is very high, is it? They're using this one hot gas. Okay, after that go to boil the water into steam. Okay, the water normally is a liquid, is it? They're using the gas to heat the water become steam. So this one we call heat exchanger. Okay, this one is a part for the reactor. So I mean the whole part they're using for the nuclear fission. Okay, now we're going to see the second part. There's a generator part. Okay, generator part, that means we got steam generator. Let's see the steam generator. Steam generator is this part, number 3. They become the steam. Okay, before they go to turbine, steam generator. Okay, we see steam generator, what's the function? To change the water become steam. When the water in the generator is heated, okay? They're using the part for boiling lah, from the water becomes steam. Okay, turbine. Turbine are rotated by flow of steam. Okay, you see turbine is one like motor. Okay, generator, like we cannot say motor because motor got battery, is it? This one turbine is no battery. They're using the relative motion. Remember, 3.3 induction. Okay, they're using the process of induction. That means now the turbine, they rotate because of the steam. Okay, the steam is too high pressure. Finally, can rotate the turbine. Inside the turbine sure got magnet. Okay, sure got magnet. After that, you got relative motion. Okay, last coil and magnet. So you see inside got coil and magnet. The coil are rotated by the turbine. Now electricity is generated by electromagnetic induction. Okay, remember when they ask about power station, they're using what phenomena? Electromagnetic induction. Okay, they're using the motion. So that means inside must have the coil and also the magnet. So after that, when you just move, okay, cutting by using the 90 degrees cutting flux, after that they will generate electricity. So this one electricity, we call it induced current. Okay, then we go to the diagram. Okay, from the diagram you refer the below the notes. Okay, let's see the first part. First part I call it the label. Fission of uranium nuclei produce energy in the form of heat. In the form of heat. Number 1, form of heat. Okay, then we go number 2. Number 2 is now the gas passing. Okay, you produce a nuclear fission, you got gas, hot gas, is it? Now the hot gas is passing through the reactor, then heat up. Okay, let's see the hot gas here. Okay, hot gas, they want to heat up the loop. Can you see the loop? Okay, inside the loop is a water. So they're using the hot gas to heat this one water. Okay, some hot gas, after you heat the water, then the water becomes steam lah. If the gas you still extra, where they go? they will come down to this part. So that's why I call you number 3. We separate by 2 parts. Okay, another part is a cool gas go back to the reactor core to be heat again. So this one, if you extra hot gas, condensation, come back, become water, then you go back to the pump, then heat again. Okay, so the 3, you can straightforward go through, become steam, you can repeat. Okay, after 3, we go to success 1. Okay, now the hot gas, you already can steam, can make the water inside the loop become steam. Okay, then we go to the part 2. Part 2, you see the number 3, heat energy from the hot gas, boil the water into steam. So that means now part 3 here becomes steam ready. Okay, now we're going to see after becomes steam. Okay, now this one steam is high pressure. High pressure, they want to turn the turbine. Okay, you see the part 4, 2 again. Okay, let's see the first part. If you are success to turn the turbine, then they say they will flow the steam to dry the turbine. That means number 4 here, you can dry the turbine. Okay, now it's a steam, is it? It's a gas, is it? So if you cannot, you got extra of the steam, where they go? Extra steam, they will condensation back, become liquid. Water again to part 4 here. So this one, part 4, we say the steam condenses back to water. Okay, if you cannot turn the turbine, that means you got extra so many steam, the steam will come down. Okay, go back to the pump, loop again. So this one is repeated. 4 got 2 parts. Success, you go to turn the turbine. Cannot success, you come back, become water again. 3 also same. If you success, you heat the water, become steam. If you not success, you come back condensation, back again, become, go back to the uranium, start again. So now we go to number 4. If you finish, if you success to turn the turbine, you see what happened? We go to part 3. Okay, part 3 from your notes. Another page. Part 3, if you success to turn the turbine, okay, now the turbine turn the coil in the generator, then produce electricity. So this is the last one. Okay, make sure you know the process. Which part should be repeat? Some is do the 2 works. Part 3 and part 4, they do the 2 works. Okay, twice, they do the twice work. First one, success, cannot success, and go back and redo. So this one is what I want to explain about the power station. Okay, let's see some diagram about the power station. Okay, let's see here. 11. Okay, this one just now I call you to draw, is it? Okay, this one, 14. Okay, this one is an example for the control rod. This part is a reactor lah. Okay, steam generator. Okay, then the steam line. This one, turn the turbine. Okay, if you cannot turn the turbine, then you come back, become water. Then you loop again. Okay, if you success generator, then generate electricity. Okay, so this part is a nuclear power station. So this part should be inside this whole thing. Okay, next we go to another diagram. Okay, this one is a process. Okay, they do the nuclear fission. After that, the steam. Okay, turbine go and generate the electricity. Okay, if not, the water repeated again. So this one is one of the animation for the power station. Okay, so we continue with the following. Okay, the following, we go back to see our, how many page? I think the last is it. Let's see the last page. Okay, let's see the last one. Okay, number 4. Okay, so this one just now is a part 3, is it? Part 3, this one is a number 5. This one I told you, this one is a number 5. When they generate electricity. Okay, then we continue for advantages and disadvantages of the nuclear fission. So from here, this one you can read by yourself. Let's see the advantages is what. The first one, they say the advantages is nuclear power. They provide a cheaper electricity, okay, than any others of the matter. Because of nuclear power station, they need less fuel. That means no need to fuel, no need using the fuel or charcoal. Okay, they're just using the uranium. So that means they say they can produce a cheaper electricity. Okay, the next one, they say they do not produce the smoke. Okay, like carbon dioxide. So they does not contribute the greenhouse effect. Okay, not like your fuel, your petrol, you need to burn, is it? They want to produce smoke. Okay, 3, they produce a large amount of energy. Sure lah, this one is compared to the hydroelectricity, or they're using the burning one, and the nuclear energy sure is bigger so many times. Okay, nuclear power station need less fuel, no need using more fuel than the normal using the fossil. Okay, safety procedure, they by using the safety procedure lah, because high technology and also advanced and also safe. Okay, number 6, remember the useful for isotope. Before that we learn medic, industry, agriculture, and also agrology. This one they say the useful for the isotope. Okay, now we're going to see the disadvantages for the nuclear fission. Disadvantages, you know lah, because so many. First, cost must be high cost, because you want to build nuclear power station. Okay, number 2, risk of accident if the chain reaction cannot control. Remember, just like I told you, if cannot control, become the nuclear bomb. Okay, number 3, expensive, required to cool down the rod. Okay, just now boron rod, is it? You want to cool down, is expensive. Okay, you want to using the procedure to cool down. Okay, now the hot water discharge from the nuclear power station can cause thermal pollution. When the water just flow to the river, flow to the sea, they produce a thermal pollution, because the water that come out is a too high temperature. Okay, number 5, the people that work in the nuclear power station, they those living nearby but exposed of the excessive radiation. If you're nearby, stay nearby, and also you work at there, you also be exposed more of the radiation. So this one is a pro and cons. We're going to see another pro and cons when they make a summary. They do the summary here. Okay, pros, let's see the pros. Inexpensive source in energy. Okay, low greenhouse effect. Power output maximum. Reliable source of energy. Positive economy impact. Okay, let's see the cons. Environmental impact. Potential of nuclear accident. Expensive and long time to build. Security threat. After that, nuclear energy is not a renewable source of energy. So this one is some of the example for the pro and cons. Okay, so our lesson just until here lah for the nuclear fission. So hopefully you understand what I'm talking about. Okay, is it? So if you don't know, you can PM me. So now is the time for you to start your tutorial. There's a 5.4. Then hopefully you understand what I'm talking about lah. Okay, so the lesson is end. So the coming lesson is a tutorial. I will mix together with the 5.5. Okay, thank you for watching.